Welcome to Geometry Pre-AP. Today we're going to do a video notes on transformations. This time we're going to talk about reflections. So you'll want to remember get the title down, get the vocabulary down, and the essential understanding. Write all those parts down at the beginning of your notes. Alright, so now that you have that down, let's go ahead and get into the problems. So in this case here, we got a few different things we're going to have to take notes on. So you can write all this down and pause the video. We want to have all of this down just to, once you get done writing it all down, make sure you go back and read it. So we have a line of reflection. When a point reflects across the line, if the point is on the line, then it does not move. That point then is across the line like point C, flips across to C prime. B flips across to B prime. The distance from B to the line of reflection is the same as the distance from B prime to the line, and that this must form a right angle. That will help you later on when you're doing some of the reflections across different lines. Remember that this is a rigid transformation. So that means that the size is kept the same, all the angles are kept the same, all the lengths are kept the same. Okay, and this is our line of reflection. All right. All right, so some of the rules that we need to know, and these are only two of the rules we need to know. There are 4 rules total, and then we have other ways we have to reflect across that aren't rules. All right, so we reflect across the x-axis. All right, you'll notice that here we have the points Q, which is 4, 3, and when we reflect across the x-axis, it comes down to here. Well, if it comes down to here, the x value never changes, and only the y value changes. And so the rule for reflecting across the x-axis is xy changes to x comma negative y. That's a pretty easy rule. You don't really have to know that rule. You probably could do that on your own on a graph. And when we reflect across the y-axis, okay, notice we're going from here over here. And so what doesn't change here is the y values don't change. Instead, the x values change. So x comma y will change to negative x, negative y. So make sure you have that rule. Those are also on your formula chart, by the way, on the back side. All right, so now here's a different one. Let's say we want to reflect across the line y is equal to negative 1. That wasn't either one of those rules. But if you remember, what's the graph of a y is equal to negative 1 line look like? And so if we just do a quick sketch, all right, and we have a graph, right? This is our x and this is our y. All right, so a y is equal to 1 line looks like that. So it's a horizontal line. And so where you're going to reflect across a horizontal line, that means it's going to go up and down. And so the x values aren't going to change, but the y values are going to change actually here. So if we're going to reflect across this, let's go do some thinking here. So first things first, we need to know how that line looks. And so if we graph that, it looks like this. So this is the y is equal to 1 line. We've got P here. We're going to reflect across to P prime. Remember, the distance from P to the line of reflection should be the same as the line of reflection to P prime. So if we look at that, that's 1, 2, 3 to that line, and then 1, 2, 3 to the other side. And so therefore we end up with the point 3 comma negative 2, which was C. Okay. So you need to know how to graph all different kinds of lines. We're going to do a lot of graphing of y equals like 2, y equals negative 1, so make sure you remember how to graph those lines. All right, so graphing a reflection. All right, so if we're going to reflect this figure across the y-axis, right? Remember there's a rule for that. Remember that when you're reflecting across the y-axis, which is this one, that the y values stay the same, but the x values change. So we graph this figure. Here we have it graphed. And we want to do the change, use the motion rule. And so xy changes to negative xy. And so negative 3, 4 changes to 3, 4. 0, 1 doesn't change at all because it's on the line of reflection. And 4, 2 changes to negative 4, 2. And so when I'm done with that, here are my new points, and this is my reflection. Notice it's a rigid transformation. It's an isometry. It doesn't change its size. It doesn't change its shape. So if you get something that doesn't look the same thing, you should know something's weird with that. Okay, so here are a couple of the other rules. So we gave you this rule already right here. We gave you this rule. But here's another one. This is the y is equal to x line, which is BA, and the y is equal to negative x line, which is negative BA. And so have those rules down also. They're on the back of your formula chart also to help you out. All right? Oops, didn't mean to do that. Okay, so a little practice here. You could do the x is equal x-axis one. All right, and I'm going to work on this other one over here. So if we go here and y is equal to negative x, that means each one changes to now I know that's b and a, so think of that as like a y and x, and this is a negative y comma negative x. And this is like changes to. So x comma y change to. All right, so in this one, we're going to switch their places, and we're going to change them to negative. So a prime becomes negative 2 comma positive 3. B prime becomes positive 1 negative 1. And I'm going to leave the last two for you to do, and so you can practice those, and you can graph them on here. Same thing over here. Make sure you get those down. If you have any questions, we can talk about those when you come to class. Actually, I don't want you to graph them. Just be all write the points down. There's not enough room on that graph. Okay. So, x is equal to negative 1. I want you to do this one. If you have problems with this one, you'll want to ask when you come to class, and we can discuss this. Remember, I did the y is equal to 1 one, so you can go back and look at that one as an example. All right, reflection across the line, y is equal to x. I'm going to do this one with you because even though there's a rule, might help you to be able to do it without the rule. So first things first, we're going to start by just graphing the line y is equal to x, okay? And so y is equal to x is the parent function, so it kind of looks like this. And this is the line y is equal to x. Yeah, I'm going to do this for this line too. All right, there we go. All right, so this is line y is equal to x. And when I do this kind of transformation, here's what I like to do. First of all, let's give our points some letters. So A, B, and C. I just count it. I don't necessarily use the rule. I just count. So remember, it has to be perpendicular. So if this one's diagonal, the other one's going to be diagonal the other way. So if I go 1.5, so I go a half and another 1, this right here is going to be my A prime. I go over C. That's a diagonal 1. So I go to the other side, diagonal 1. That's C prime. And this one's going to be 1, 2, 3, and a half. So there's a half. 1, 2, 3. And so this is where B prime is. And so then when I connect these, there's my figure. There's my A prime, B prime, C prime. And so I like to count, but if you can remember the rule, that's fine. Remember the rule. All right. So here's one for you to do. You can pause the video and do this one. Okay. And here's another one for you to do. Reflect across line y is equal to line is equal to x is equal to 1. Just giving you some more practice with that to different figures. And finally, you should be able to reflect any figure across any line that is graphed. I especially want you to be able to do the like lines x is equal to 3 and y is equal to negative 2, y is equal to x, y is equal to negative x, and of course the axis. Be able to reflect across any of these kinds of lines.